Hello guys, welcome to another brand new video of Code and Clarity. Today we will be discussing about object-oriented programming in Java. Imagine you are playing with some blocks. Each block can be thought of as a piece of data, but when you assemble them into a car or a house, you have a complete object with both structure as well as purpose. That's exactly what object oriented programming or OOP does. It takes small pieces of code, that is data and actions, and bundles them together into objects that represents the real world things. So instead of thinking in terms of just steps or functions, we think in terms of things and how they behave. So, object oriented programming is basically a programming paradigm where programs are organized around objects rather than function or logic. So, in case of object oriented programming, we have some attributes as well as their functions and they're encapsulated together. So, I'll be telling everything in detail. Please hold on. I'll be giving real world examples and explaining in simple terms. Why object oriented programming? Think about a car company making different models of cars. They don't redesign everything from scratch for each and every model. What they do is they reuse parts, tweak designs, and only make the changes wherever necessary. That's what object oriented programming does for programmers. It helps us reuse the code, keeps the things organized, and make changes without breaking everything else. So, they model the real world entities much more naturally. Promotes code reusability and modularity, also makes large program reusable and also enhances the security. Now we'll be discussing about the concepts of object-oriented programming. So there are two basic concepts on which OOP stands, that is classes and object. So what is a class? A class is like the blueprint of a house. The blueprint, what is a blueprint? The blueprint has details like the number of rooms, where the kitchen will be, and how the doors will open, but still it's not a real house yet. In code 2, a class defines the properties, that is the data, and the methods, that is the actions the object will have. For example, a car might say every car has a color and can drive. But until you can actually build the car, you just have the plan. So here see in the class car, the string color is the attribute and the void drive is basically the function. Got it? What is attribute and what is function or methods? Now we'll be discussing about the objects. So what is an object? An object is the actual house built from the blueprint. Now if car is the class, then your red Honda Civic is an object. Similarly, my black BMW is another object. Both are made from the same design, but with different detailing. In case of programming too, objects are created from classes and can have their unique values for properties while still they're sharing the same behavior. So here using the example we have explained, now my car is the object, the attribute that is color is same of like that of the class. The function drive is same, but the value of the attribute is different in case of different objects. Similarly, the definition of drive, like we can call drive, we may not call drive in case of objects. So this is what object is. Now we will be discussing about the four pillars. What are the four pillars? The first pillar is the encapsulation. So what is encapsulation? Think of your ATM card and bank balance account. You can check your balance or withdraw money from that account, but you can't directly access the bank's database to change your balance. This is what encapsulation is. Hiding the inner details and only exposing the controlled access through methods like deposit or withdraw. In case of code, we use private variables and getters or setters to control the access. So let's see here, wrapping the data and methods into a single unit. Okay, and the access is basically controlled using access modifiers. So there are basically four types of access modifiers: uh, private, public, protected, and default. Private allows access only within the class. Public is accessible from everywhere. Protected allows access within the same package and subclasses. And the default allows access within the same package. Now, this encapsulation is achieved using getters and setters. So here we are seeing a class. The balance is the attribute, and the method get balance is the getter, and the method set balance is the setter. The get balance is basically used to retrieve the balance, and the set balance is used to set the balance. I hope entire concept of encapsulation is clear. So basically, wrapping the data and the methods into a single unit, that is a class. It is basically, if you see the capsule wraps the medicine within it. From the concept of capsule only, the term encapsulation rises. Now I'll be discussing about the second pillar, that is inheritance. So what is inheritance? Inheritance is like a family tree. You inherit traits from your parents, like maybe your father's height or maybe your mother's eye color, but you can also have your own traits. In programming, also, one class can inherit from another. For example, car might be a child of vehicle, so it automatically gets the ability to start or stop, but it also can have its own feature, like opening sunroof. So, inheritance allows a class to acquire the properties and methods of another class. The class which inherits is called as the child class or the subclass, and the class from which it inherits is called as the parent class or the superclass. So it basically promotes the code reusability, and it is achieved using extends keyword in Java. So here the code snippet is given. So the vehicle has the function start. So the class card, which is basically the subclass within the parent class vehicle, has another function which is honk. So this car class has both the properties and both the functions, like both start and honk. It inherits the start function from its parent class. So this is basically the concept of inheritance. Now we'll be discussing about the third pillar, that is the polymorphism. The polymorphism word may sound fancy, but it just means many forms. Think about the word run. A human runs, a dog runs, a program can run. So the same word is used, but it's done differently depending on who or what is doing it. In code also, we can have the same method name but different implementations. That's polymorphism basically. So polymorphism is the ability to perform a single action in different ways. Now, what are the two types of polymorphism? Compile time polymorphism and runtime polymorphism. Compile time polymorphism is known as method overloading. In case of method overloading, same method name but different parameters. And the runtime polymorphism is called as method overriding. In case of method overriding, we have the same method name and parameters which are redefined in subclass. Now, here's an example of method overloading. See, in the class math utils, we have the add function, and within the add function, the two integer parameters are passed. And the next function name is also add. In that case, the two double parameters are passed. So while the function will be called if the parameters passed are double, then we will be calling the second add function. The program understands using the data type that which add function is basically called. So similarly, in case of method overriding, the concept is a little different. So in the class animal, the sound is basically the defined in the class animal. So the when the class dog actually extends animal, again, again the definition here is different of the same method. So when we will be calling the object from the dog class, and then we will be calling the sound function, then obviously in that case the second method will be called. That is basically the method overriding. Now let's move on to the fourth pillar, that is the abstraction. So what is abstraction? Abstraction is like driving a car without knowing how the engine works. You just turn the key, press the pedal, and it goes on. The complex parts are hidden from you. In programming, abstraction hides the complex logic and shows only what is necessary. We do this with abstract classes and interfaces. So, hiding the implementation details and showing only the essential features. These are achieved using abstract classes. Abstract classes cannot be initiated, may have abstract and concrete methods and interfaces. Only abstract methods until Java 8 now can have default methods too. Now, in this case, abstract class shape, we have the abstract function draw. but we only have the declaration of the function here, okay? And in the subclass which inherits the parent class, we define the function. So this is basically the concept of abstraction. In the abstract class, we are just giving the declaration and we are calling it in the next part. So what are the now we will be discussing the advantages and the disadvantages. What are the advantages of object oriented programming? OOP is like a well organized kitchen. Modularity. See, every drawer or shelf has a purpose in kitchen. Similarly, reusability. You can use the same knife for many recipes. Next is security. Dangerous tools are stored out of children's reach. Encapsulation, okay. And flexibility, like you can cook different cuisines using the same set of tools, that is the polymorphism. So, code is organized into small and manageable units. Inheritance allows reuse of existing code. Encapsulation basically protects the data, and polymorphism allows one interface and many implementations. And what are the disadvantages? See, it is much more complex for small programs, and it also causes performance overhead due to the abstraction layers. Means if your program is small, then no need of this much all implementations. It takes time to. Now we'll be discussing a real life example. So let's tie it all together with a banking system example. Class. So what is the class name? Account. This account has account number and balance. Now what is the object? Your actual account at the bank. Now let's see encapsulation. You can't directly change the balance. You can only do it through deposit or withdraw methods. Now, what is the inheritance? Savings account and current account, they inherit from the account. Now, polymorphism, both the accounts have and calculate interest method, but they do it different. And what is abstraction? You don't know the complex formula for interest, the bank handles it manually. So, this is the example of the banking system. Now, this is all about object-oriented programming in simplest terms. So, if you know, if you want, then I can discuss the method overloading, method overriding, etc., abstraction interfaces, etc. In a separate video. Please let me know in the comments, and please like the video, subscribe to my channel, and write in comments what topic you want my next video. Have a good day. Bye. Thank you. Subscribe.